Hello my dear friends, how are you all? I hope you all are good and fantastic. So my dear friends, you are very welcome in our lecture number 4 of areas related to circles. Okay, so my dear friends, in this lecture we are going to solve a lot of problems. Okay, so now I hope you will enjoy this lecture. So let's start without wasting the time. So now my dear friends, today we are going to discuss areas of combinations of plane figures. Okay, so my dear friends, in this lecture we have some problems of the combinations of plane figures. Okay, so there is not a big task to solve these questions, but you have to apply the what? Yes, you have to apply their concepts. Okay, and you have to remember all the formulas which we learned in the previous classes. Okay, so all these formulas are going to help to solve these questions. Now the question number 1 is, find the area of the shaded part in the following figure. We have a figure ABCD, which is a square of side 28 centimeter, and has 4 equal circles enclosed within. So now my dear friends, in this figure we have to find the shaded part, means this yellow part. Okay, and in this figure we have a square, and in this square there are 4 circles. There are 4 equal circles. Okay my dear friends, so the area of the shaded part is calculated as, we can write it as area of shaded region is what area of square minus area of 4 circle. Okay, if we subtract area of 4 circle from the area of square, then we get the area of the shaded portion. Okay my dear friends, so now my dear friends, we have to find the area of square. So area of square is what? We know that the area of square is side square, and the side of this area is 28 centimeter. Okay, so 28 square, so we get 784 centimeter square. So this is the area of square. Now we have to find the area of the circle. So if we find the area of first circle, then we can easily calculate the area of 4 circle, because the area of these circles are equal. Okay, so the area of first circle, we know that area of first circle is pi r square. And what is the value of r? Now the question comes is that what is the value of r, means radius. Now we know that from this point to this point, this is what? This is diameter, and this is the half distance of the square side, means it is equal to 14 centimeter. It is equals to what? 14 centimeter. So we know that diameter is equals to 14 centimeter. So we can write the radius is equals to d upon 2. So this is equals to 14 upon 2. So this will give 7 centimeter. So we have radius is what? 7 centimeter. So my dear friends, area of first circle is pi into 7 square. So this will give 22 upon 7 into 7 into 7. So this will give 22 into 7. Okay, so now my dear friends, area of 4 circle, this is the area of one circle. Now the area of 4 circle, so we can multiply it by the area of first circle. So this will give 4 into 22 into 7. If we multiply this, we get 616 centimeter square. What? 616 centimeter square. Okay, my dear friends, I hope you get this point. So now we have area of square and area of these circles. So we can find easily the area of shaded region. Okay. So now, my dear friends, okay, area of shaded region is equals to area of square, which is what? 784 minus area of circles. So what is the area of circle? 616. So with the help of this, we can find the area of shaded region, which is 168 centimeter square. So this is the what? Area of shaded region. I hope, my dear friends, you understand this method. So my dear friends, this is the method to solve these questions. Okay. So let's move on to the next question. So the next question is, question number 2 is, find the area of the shaded region in this figure. Okay, again we have to find the area of shaded region in this figure if PQ is equals to 24 centimeter. Now we have PQ which is equals to 24 centimeter, and we have PR, this line, PR 7 centimeter. Okay, my dear friend, and O is the center of circle. It means RQ is the diameter of the circle. RQ is what? Diameter of this circle. So my dear friends, this is the question, this is the diagram. Now let's start to solve this question. Yes, so now my dear friends, we know that here is in this diagram, P is the angle. P is the angle in this semicircle. So we can say that P is in the semicircle. So angle QPR is equals to what? 90 degree. So this is what? 90 degree. So we can say that, triangle PQR is right angle triangle. Is what? Right angle triangle. Okay, my dear friends, I hope you understand these things. So now, my dear friends, in this right angle triangle, QR is what? Hypotenuse. QR is what? Hypotenuse. Okay, I hope you get this point. So we can find this hypotenuse with the help of RP and PQ, because we know the value of RP and PQ, so we can easily find. So by Pythagoras theorem, we can find QR whole square is equals to PR square plus PQ square. So this will give, what is PR square? It is 7 square plus what is PQ square? Means 24 square. So if we solve this, we get 625. What is? Yeah, 625. So if we take under root both the side, so we get QR is equals to 25 centimeter, which is equals to what? Which is our diameter, which is the diameter of the circle. Okay, my dear friends, I hope you get this one. So now we have diameter of this circle. So with the help of this diameter, we can easily find the area of semicircle. So how we can calculate the area of shaded part? We can calculate it by, let's suppose this is the shaded region. This is what? Yes, this is shaded region. Okay, So we can calculate this part by subtracting this area of triangle from the area of semicircle. If we subtract this area of triangle from the area of semicircle, then we get area of this shaded part. Okay, so we can write here as area of shaded part is equals to what is? Yes, area of semicircle minus area of triangle PQR. Okay, now find the area of semicircle. So area of semicircle is what? Pi r square by 2, because this is the half of the area of square. Okay, so we have 22 upon 7 into what is the value of r? So we know that the diameter, which is 25 centimeter, so it is 25 upon 2 into 25 upon 2, and there is another 2, which is this. Okay, so now if we solve this, we get 245.54 centimeter square. What is? Yes, 245.54 centimeter square. Okay, my dear friends. Okay, now let's find the area of triangle PQR. We know that what is the area of triangle PQR? Half into base into height. What is base? So if we observe this figure, okay, if we observe this figure, we have a base is PQ and height is what? Yes, height is PR. So we have PQ, which is 24, and we have PR, which is 7. So we can write it here like this: half into 24 into 7. Okay, so this will become 12 into 7. So if we solve it, we get 84 centimeter square. What is? Yes, 84 centimeter square. So now we have the area of semicircle and we have area of triangle. Now subtract the area of triangle from area of semicircle. So we get what? Area of shaded part. So area of shaded part is equals to what? We have area of semicircle 254.54. 254.54 minus area of triangle is 84. Area of triangle is 84. So after solving this, we get 161.54 centimeter square. 161.54 centimeter square. So this is the area of shaded part. Okay, so I hope, my dear friends, you understand these things. So now, my dear friends, let's move on. Yes, so the next question is, find the area of the shaded region. Same in the figure. If radii of the two concentric circles with center O are 7 cm and 14 cm. Okay, my dear friend. And we have an angle AOA, which is 40 degree. Which is what? 40 degree. Now let's understand the concept of this question. Okay. So now, my dear friends, we have two radius. First of this circle is 7 cm and second of this circle, which is 14 cm. Okay. Now we have to find this region. For finding this region, we can solve it by first finding the area of sector of the upper square. Okay, and find the area of this sector of the small or smaller circle. Okay, and subtract both of these, so we get the shaded region. Okay, so now let's find the area of sector AOCA. Area of sector of AOCA. So now first is area of sector AOC. Area of sector AOC. So what is this? This is theta upon 360 into pi r 1 square. So we have theta is what? 40 and this is 360. Multiply 22 upon 7 and we have R1 is 14, which is 14 into 14. Now 14 is cut by 7 by 2 times. Okay, and this 0 and this 0 will be cancelled. Okay, my dear friends. Now 36 can be solved by 4. How many times? 9 times. So we have what? We have 22 into 2 into 14 divided by 9. Divided by what? 9. If we solve this, we get 68.44 centimeter square. Okay, my dear friends. So now, my dear friends, we have to find the area of sector of BOD. Okay, so let's find that. Area of sector BOD. What is? Theta upon 360 into pi r2 square. So theta is 40 and divided by 360 into 22 upon 7 into what is second radius, which is 7 centimeter. Which is what? Yes, 7 centimeter. So we can write it here 7 into 7. So this will be cancelled from this and 1 0 is cancelled. This will goes to 9 times. So we have 22 into 7 upon 9. What is? Yes. Now if you solve it, we get 17.11 centimeter square. So first answer is 68.44 centimeter square and the second is 17.11 centimeter square. Now if we solve this, so area of shaded region is what? Is area of sector OAC minus area of sector BOD. Okay, so this will be equals to 68.44 minus 17.11. So now if we solve this, we get, yes, we get 51.33 centimeters square. So area of shaded region, which is equals to 51.33 centimeters square. I hope, my dear friends, you understand these things. Okay, so now, my dear friends, this is the method to solve the question. So now let's move to the next question. Yes, question number 4 is find the area of the shaded region in this figure where a circular arc of radius 6 cm has been drawn with vertex O of an equilateral triangle OAB of side 12 cm at the center. Okay, my dear friends. So now, my dear friend, in this case, we have to find the shaded part, means we have to find the whole figure. We have to find the area of whole figure. Okay, how we can solve it? So let's understand the concept of the solution. So my dear friends, we can find the area of the shaded part by solving the area of circle, okay, plus area of this triangle. But my dear friends, this sector, the area of this sector is common in the area of circle and area of triangle. So now we have to remove this. So the area of the shaded part is what? Area of circle plus area of triangle minus area of this shaded part. Okay. So this is the method to solve this question. So first of all, we have to find the area of this square. So let's find the area of the square. So area of square is equals to pi r square. And what is radius? Radius is 6 centimeter. So 22 upon 7 into radius is what? Yes, 6 into 6. So we get, if you solve this, 792 upon 7 centimeter square. Okay, so this is the area of a square. Now find the area of this triangle. Basically this is what? This is a equilateral triangle. This is a equilateral triangle. Okay, my dear friends. So now area of equilateral triangle is, the area of equilateral triangle is root 3 upon 4 into side square. Into what? Side square. So we know the value of AB is what? 12 centimeter. So we can find area of triangle OAB, which is equilateral triangle. So this is equals to root 3 upon 4 into what is? Yes, this is 12 into 12. Side square means, and we have a side is 12, so this will become 12 into 12. Now 12 can be divided by 4. How many times? By 3 times. Okay, so now we have 36 into root 3. What? Yes, 36 into root 3. So this will become 36 root 3 centimeter square. So this is the area of triangle OAB. Okay, now we have to find the area of this sector. Okay, so find the area of sector. Area of sector is equals to theta upon 360 into pi r square. And we know the value of theta. Theta is, so my dear friends, we know that this is equilateral triangle, and in equilateral triangle all angles are what? 60 degree. All angles are what? 60 degree. So we can write here as 60 upon 360 into 22 upon 7 into r square. Now what is r? R is, we have 6 centimeter. So we can write it here 6 square. So this will become 1 upon 6. So 1 upon 6 into 22 upon 7 into 6 into 6. And 1 6 and 1 6 will be cancelled. So we get 22 into 6 upon 7. If we solve it, we get 132 upon 7 centimeter square. So my dear friends, I hope you understand these things. So now let's find the area of this shaded portion. Okay, so the area of shaded region is equals to area of circle plus area of equilateral triangle minus area of sector. Okay, my dear friend. So what is the area of circle? So the area of circle is 792 divided by 7 plus area of equilateral triangle is 36 root 3. Now the area of sector is what? Minus 132 upon 7. Okay, my dear friends, I hope you get this point. So now we get 36 root 3 plus, we take from these two terms, we take the LCM is 7. So 792 minus 132. So this will become 36 root 3 plus 660 divided by 7. Okay, 660 divided by 7. So my dear friends, this is the answer. This is what? Centimeter square. So area of shaded region is what? 36 root 3 plus 660 upon 7, okay, centimeter square. So I hope my dear friends you understand these things. Okay, so now let's move on. Yeah, so the question number 5 is, from each corner of a square of side 4 centimeter as quadrant, as what? As quadrant of a circle of radius 1 centimeter is cut. Okay, and also a circle of diameter 2 centimeter is cut as shown in this figure. Find the area of the remaining portion of the square. So this question is saying that we have a square of side 4 centimeter. Okay, I hope you get this point. And from each corner a quadrant is cut of 1 centimeter of radius, and also there is a circle in the center of diameter 2 centimeter. Now we have to find the remaining part. Okay, so how we can find it? We can find it, first of all we have to what? Yes, we have to find the area of the square. Okay, and from this we have to subtract the area of 4 quadrants, area of 4 quadrant, and we have to subtract the area of this circle. Okay my dear friends, now if we find the area of 1 quadrant, then we can find the area of 4 quadrant automatically, because the area of 1 quadrant, okay, is equals to this area of the second quadrant, to the third and to the fourth. Okay, so from this if we find the area of 1 quadrant, we can multiply it by 4, then we can find easily the area of the four quadrant. Okay, so now let's find the area of these. Okay, so first of all, area of square. What is area of square? Side square, which is 4 into 4, so this is 16 centimeter square. Okay my dear friends, so now area of 4 quadrants. Area of 4 quadrant, what? Yes, so this is equals to 4 into area of 1 quadrant. So area of 1 quadrant is 1 upon 4 into pi r square. 1 upon 4 into pi r square, because this is the fourth part of the area of the square. So this 4 and this 4 will be cancelled, so we get pi r square. So this is equals to 22 upon 7, and radius is what? 1 centimeter. So we can write it here 1 into 1. So we have 22 upon 7 centimeter square. So this is the area of 4 quadrant. Okay, now we have to find the area of the circle. So area of the circle is area of circle. So this is equals to, we know that, pi r square. Okay, and radius is what? 1. So we can write here as 22 upon 7 into r is what? 1 square, means this is 22 upon 7. 22 upon 7. Okay, I hope you get this point. Yes, so now we have to find the area of this shaded part. Area of this shaded part. So this is what? This is the area of square minus area of 4 quadrants minus area of circle. Okay, so we have area of shaded part. Okay, so the area of shaded part is what? This is area of square area of square minus, this is area of 4 quadrants minus area of one circle. Okay, means we are talking about this circle. Got it? So what is the area of a square? So the area of a square is 16. So we can write here as 16 minus. Now what is the area of 4 quadrants? So this is what? Here is, this is 22 upon 7. This is 22 upon 7. So we can write 22 upon 7 minus. Similarly, this is again 22 upon 7. Okay. Yes, so now if we solve this, we get, okay, so here is 7 is the LCM. Okay, now in the denominator this is 1. So if we divide, we get 7, and 7 into 16 is what? 112. Okay, minus 22 minus 22. So 22 minus 22. Okay, so this will become 112 minus 44 divided by 7. Okay, so this is 68 upon 7 centimeter square. So the area of this shaded part, means this area is 68 upon 7 centimeter square. So we can write here as area of shaded part is equals to 68 upon 7 centimeter square, is equals to 68 upon 7 centimeter square. So I hope you understand these things, my dear friends. Okay, yes, so now let's move on. Yes, so the next question here is, in figure ABCD is a square. Here is, we have ABCD, which is what? Which is a square. So this is a square. Okay, of side 14 centimeter, with center A, B, C and D of 4 circles are drawn such that each circle touches externally 2 of the remaining 3 circles. Means like this. Means these circles, means each circle touches externally the 2 circles, means at this point and this point. Okay, each circle. So now find the area of the shaded region. So we have to find the area of this part, shaded part. So how we can find it? So we can find it as, if we find the area of a square, okay, and if we subtract the area of these quadrants, area of these quadrants from the area of this square, we get the area of the shaded part. Okay, so first of all, area of square ABCD. So this is what we know, that this is side square. Okay, this is side square, and this side is what? 14. So this is 14 square. So this is equals to 196 centimeter square. Okay, now we have to find the area of these 4 quadrants. Okay, so we know that here is, let's suppose this is point E. Okay, and AE is the radius of this circle. Means we can say that AE is the radius of this quadrant also. Okay, this quadrant. So if we find the area of one quadrant and we multiply by 4, we get the area of these 4 quadrants. So here is area of 4 quadrants is equals to 4 into area of 1 quadrant. Okay, and the value of radius, means the value of AE is what? AE is half of the AB. So here is, we know that this is 14. So this will become AE is 14 upon 2. So this is equals to 7 centimeter. Okay, so the radius is what? Radius is, in this, R is 7 centimeter. Okay, I hope you get this point. So now the area of 4 quadrants, which is equals to 4 into area of one quadrant, which is 1 upon 4 into pi r square. Now what is the value of r? 7 centimeter. So now if we put the values, so we get this 4 and this 4 will be cancelled. So we have 22 upon 7 into 7 into 7. And we can cancel this 7. So we get 22 into 7. Okay, my dear friends. So this will become what? Yes, this will become 154 centimeter square. Okay, my dear friends. So now, my dear friends, area of shaded part is equals to, what is the area of shaded part? Yes, we can easily find area of square minus area of 4 quadrants. Area of 4 quadrants. 196. Okay. Minus area of 4 quadrants is 154. So this will give 42 centimeter square. Okay, my dear friends. So this is our answer. Okay. So now let's move on. So the question number 7 is, my dear friends, in the given figure, a square OABC is inscribed in a quadrant OPBQ. Okay. If OA is equals to 20 centimeter. Now we have to find the area of shaded region and we can use the value of pi is 3.14. Okay. So my dear friends, again we have to find the area of this shaded region. This shaded region. For this, my dear friends, firstly we have to find the area of this quadrant and then we have to find the area of this square. After finding the area of these two figures, we have to subtract the area of square from the area of quadrant. From what? Yes, from the area of this quadrant. Okay, my dear friends, I hope you get this point. So now, my dear friends, for finding the area of this quadrant, firstly we have to find the area of radius, which is what? OB, which is OB. Okay, now we have the value of OA is what? 20 centimeter. So basically this is a square, so the value of OB is also 20. Okay. And my dear friends, if you observe this, this is what? This is the diagonal of the square. This is what? This is the diagonal of the square. Okay. So with the help of this triangle OAB, this is a right angle triangle. This is because this angle is 90 degree. So in this triangle, we can find OB. So by Pythagoras theorem, OB square is equals to OA square plus AB square. This is what? Pythagoras theorem. Which is hypotenuse square, base is equals to base square plus perpendicular square. Okay. So OB is what? Our hypotenuse. Base is we have OA and we have perpendicular is AB. Okay. So now, my dear friends, what is OB? We have to find it OB. What is OA? Which is 20 square and same here is 20 square. So this will give 400 plus 400, which is equals to what? 800. Okay, now if we solve it, we get OB is equals to under root at 800 and this will give 20 root 2 centimeter. So we have OB is 20 root 2. So this is the radius of this quadrant. Okay, my dear friends. So now we can easily find the area of quadrant is what? Area of quadrant is 1 upon 4 into pi r square. Okay, 1 upon 4 into pi r square, and this is 1 upon 4 into. Now the value of pi we have to use 3.14 into, and the radius is 20 root 2 whole square. Now if we solve this, we get, so we have area of quadrant 1 upon 4 into 3.14 into 20 root 2 into 20 root 2. Okay, now from this 4 we can cancel the 20 by 5 times, and 5 into 20 is what? 100 into 3.14 multiply, here root 2 into root 2 is 2. Okay, so if we remove this point, we get 100 in the denominator. So this 100 and this 100 will be cancelled. So we have 314 into 2, and if we solve this, we get 628 centimeters square. So this is the area of quadrant. Now we have to find the area of square. Area of square. So this is side square, and the side is 20 square. So we get 400 centimeter square. So the area of shaded part is what? Shaded part is what? 628 minus 400. So we get 228 centimeter square, because we are subtracting the area of square from area of quadrant. So this is the answer. So my dear friends, I hope you understand these questions, how to deal with these questions. Okay, so they are the questions of the combined figures. Okay, in these we are finding the area of the combined figures. Okay, my dear friends, so now my dear friends, this is enough for today, and we will meet in the next lecture with the next amazing topic. Okay, so thank you very much guys for listening me, and take care and goodbye.